Hey guys, this is a lesson on systems of equations. We're going to look at how to solve systems using three methods. First by graphing, and that's the method we'll use the most often. But you need to be able to solve them using graphing. But then you also have to understand the process of solving them algebraically. So that's going to be using methods called substitution and elimination. So really, on your state test on this stuff, if a question asks you to just give the solution to a system, graphing is going to be your best bet for that, because you're able to give those solutions very easily and very quickly without making any kind of mistakes. But there will be questions also that ask you specifically about the methods of substitution and elimination. So I'm going to show that to you, but know that you're not really going to have to use that for solving. You're going to have to use that to be able to come up with an answer to like a question about the method, but you won't actually have to carry the whole method out to be able to solve. So just to give you kind of an idea of how that's going to work. So let's get into what this means to solve with graphing, and we'll look at how that works, and then we'll go into the other two algebraic methods. So a system of equations is a set of two or more equations with two variables. So if they give you a system, they're going to give you two equations with x's and y's. So it'll be like y equals 2x plus 3, and then y equals 3x minus 4. Two equations together that have to be solved. So the solution to a system is an ordered pair. So it's a point. Just like the solution to an equation is any point that's on the line, the solution to a system of equations is one single point. It's an ordered pair, an x, y, and that represents the point where the lines cross each other. So if you got two equations, you're going to have two lines. The point where they cross, or the point where they intersect, is the solution to those. That represents the point that makes both equations true at the same time. So the point that lies on both equations, or both lines, represents the solution to that system. All right. So there are three types of solutions, just like there are three types of solutions to normal equations. So when you're graphing systems of equations, you could have one solution, and that's going to exist if the lines cross one time. So that's a situation where you could take a line like this, and you could have another line like this. And this point where they touch each other represents their solution. That one spot where they cross. They're only crossing once. So other things you could have if you graph two lines, other than them crossing each other, you could have two lines that never touch. Right? Lines like that never touch and never will touch. If they kept going forever, they still would never touch. That's going to be something that has no solution. So we can do that like that. That means your lines are parallel. They can never touch each other. And then the third option you have would be if you were to graph a line, and then you graph the second line, and it ended up being the exact same line. Right? They're right on top of each other. If that happens, then there's an infinite number of solutions because the lines are the same. They touch everywhere. All right. So let's look at how we do this in Desmos to solve them with graphing. So the easiest way to solve a system, and again, like I said a minute ago, the way that if you see a question that says find the solution to this, the way I want you to do it is just to graph it. That's the easiest way to make sure you get it right every time. Don't make a mistake. Don't have any kind of errors in there. So best option is to graph it because we have access to Desmos. So use Desmos to graph both lines together. Then find the point where the lines cross. Now, obviously, if they don't cross, if it looks like one of those situations we looked at on the other page, then you're going to give the answer as either no solution or infinite solutions. But if they cross, you find that point, and that point is your solution there. So let's look at some examples of this. And I'm going to pull Desmos up so we can see it. If I wanted to find the solution to this y equals negative 2x plus 3 and y equals 3x minus 2 system, I'm just going to graph those. Y equals negative 2x plus 3. Y equals 3x minus 2. And I'm going to find that solution. Now, you see that there are two lines crossing each other. If I want to find their solution, I'm going to tap the middle of them to see the point where they touch. They touch at 1, 1. Yours will also show you the point. You just have to tap it. 1, 1. Now, I'll show you this, though. If you were to be zoomed way out, I don't know how that just happened, but wait. Let me click on this and do it. Come back to life. Oh, my goodness, y'all. I'm touching the wrong thing. Sorry. So if I were to be here, sorry about the lines, I just drew all over that trying to mess with that. And I zoomed way out. Do you see how it's really hard to tell where these things are crossing? And there are a whole bunch of different points that exist here. And if I'm not real careful about where I touch, I'm going to get one of the intercepts instead of getting the point of intersection for these. So make sure you can actually physically see the point where they cross each other before you decide that you've gotten that point by being way zoomed out. And if you're not sure and you want to just get kind of back to normal, because a lot of times y'all will ask me questions about stuff, and it's usually because you're zoomed way out for whatever reason. Remember, the home button will zoom you back to normal, and usually that'll help you so you can see it. So just be real careful with that. If you ever can't see it, like let's say it wasn't right there and it was way over here somewhere, just pan around until you find the point of intersection. You may have to move things around a little bit. But it's real easy to get the answer there if you've got that in the right spot. So let's do the second one. So we have y equals 3x and y equals 3x minus 2. So I'm going to change this one to y equals 3x. And then I have this graph. And so if you look at that, you notice that no matter where I go, they don't ever get any closer together. They're never crossing each other. And that's because these lines are parallel. And just like we said on the other slide, parallel lines never touch, which means there's going to be no solution for this because those lines are parallel. So I'm going to write no solution, or you can write that little 0 with a line through it. That represents no solution. All right, let's do a couple more and then I'll let y'all try a couple. So same deal here. I'm going to pull Desmos back up. 2x plus y equals 3. 2x plus y equals 3. Y equals x plus 3. My two lines cross each other right here. So my point of intersection is 0, 3. Now sometimes these questions will ask you stuff like, what is the x value that makes both equations true? If they ask you that, they don't want the whole point, they just want the x part of it. So you're just going to give the 0 from it. Or what is the y value that makes both equations true? They just want the 3 from the point. But this point represents the whole solution. So depending on what they're asking you for there. And then this last, we'll do one more together and then I'll let y'all do a couple. Oops, wrong button. Let's just do this. Hello, why do you hate me? Okay, there. 2x minus y equals 2. 2x minus y equals 2. And y equals 2x minus 1. Y equals 2 times x minus 1. Okay, so I get this. So notice with this, if I zoom out, I'm still only seeing one line. And the reason for that, see, I've zoomed way, way out. Like I'm at 200,000 and I'm still only seeing one line. And the reason for that is that my lines are actually both exactly the same. And you can see that if I tap the little colored circle, I can make one hide and the other one show up. So you can see how they're overlapping on top of each other because they are exactly the same line. And remember, lines that overlap everywhere, they touch everywhere, they have an infinite number of solutions. So we would call this infinite. Or you can draw an infinity symbol if you want. Okay. So take a second, put these in Desmos and get an answer to them, and then come back and see if your answer was correct. All right, if you graph both of those, you should have gotten the point of intersection at 1, -4. And then for the second one, you would have gotten no solution. If you didn't get that, go back and regraph them and then look at it again. The second set of lines came out parallel, so they never touched each other. And the first set crossed at +1, -4. All right. So that's graphing. Graphing systems is very, very easy. And again, that is the best option if they just ask you for a solution, for you to get that and make sure there's no mistakes. However, you are allowed to use Desmos on your state test, and that's great for this year. But next year and in years after that, Desmos will not be a tool that you can use anymore. You will just be limited to the TI-84 graphing calculator, which is capable of graphing and finding solutions to a system, but they have to be in y= form to be able to do it. So it's a little bit harder. But additionally, you'll have some situations where you're not able to just graph them and find their solution. You're going to have to be able to solve them algebraically too. So I'm going to show you that. There will be questions on your test and questions on your state test specifically about these two methods. They're not necessarily going to ask you to solve with a certain method, because it doesn't actually matter what method you use to solve. You're still going to get the same answers. But they will ask you to be able to answer questions about the process, especially about elimination. I see questions about that pretty often. So we're going to look at all that today to make sure you have a basic understanding of it, so that when that does roll around, you'll be able to do it and do it correctly. So let's talk about the two options. There's substitution and there's elimination. Substitution is typically used when one equation is in slope-intercept form, or it could be in x= form. So we're going to call it either y= or x=. And the other one is in standard. So remember, standard is both on the same side. Substitution can be used if one equation is solved for either variable. So if you've got either equation that is y= or x=, substitution is a good method. Elimination is only able to be used when both equations are in standard form. So you have to have both equations with x and y on the same side. All right, so let's look at substitution first. So if you're going to do substitution, remember, a substitute is something that can take something else's place. So I always use the analogy of like baseball. If you were playing baseball and you had somebody on the pitcher's mound throwing, and you needed to take that person out and put someone else in, you would be making a substitution. You would only ever do a substitution like that with somebody else who is also a pitcher. You can't do a substitution with somebody who plays outfield necessarily, although maybe they're capable of pitching. But if they're not a pitcher, then you're not going to substitute a pitcher for a catcher. You're not going to substitute your pitcher for your shortstop. So you want to make sure that you're doing substitutions that are equal, and that's basically what we do in math too. So when you're doing a substitution problem, you're going to look at the two equations and figure out which variable has already been isolated, because that's going to be the thing you substitute. That's when you're going to replace. I'm going to put replace instead of substitute because it's shorter. Then once you've figured out what you can replace, you're going to actually go in and do that substitution. So you're going to substitute the y= or the x= expression in place, or in the other equation, in place of whatever x or y is. So if you know what y equals, you're going to put that in place of y. If you know what x equals, you're going to put that in place of x. So you're putting whatever expression in place of that variable. Once you've done this, if you've done it correctly, your equation will only have one variable. Now, it may have more than one of that, like it could have two x's in the equation, but you're only going to have x's. You're not going to have x's and y's anymore. So if you still have two different variables, you've messed up and you need to go back and try again. So once you do your substitution and you replace the y with what it equals, or you replace the x with what it equals, then you're going to solve the equation for the remaining variable. Once you do that, you're only going to have half of the ordered pair. You're going to have the value of one of the variables. So then you have to substitute the number you get, or the value, I'm just going to put number, you get for that variable in either equation, doesn't matter which one, and solve for the other variable. You have to get two answers. You have to have an x and a y. So if you only get to step 3 and you only solve for one letter, you're missing half of your answer, and your answer will be wrong. So you got to make sure you solve for both. All right, let me show you what this means, like in a really like 3rd grade level sense of what substitution actually is. If you have a basic elementary equation like 2 plus 3 equals 5, or 2 plus 5 equals 7, substitution means I can take this, and because I know that 2 plus 3 is equal to 5, and I have a 5 in this equation, I can substitute the 5 down here for the thing 5 is equal to, which means I could make a new equation, 2 plus, and instead of putting 5, I could put 2 plus 3. And I should still have a true equation because I was able to do this substitution. And I do. 2 plus 2 plus 3 is also equal to 7. So I've done a substitution there. I could do the same thing in the second equation down here, where I know that 7 is equal to 2 plus 5. So I can then come down here where I have a 7 and substitute it for the thing that 7 is equal to. So if 2 plus 5 is equal to 7, then I can replace the 7 down here with 2 plus 5, and I should still have a true equation. That's what substitution means. It means you're taking something out and putting something equivalent in its spot. You can only do substitution when you know what something is equal to. I can only substitute here because I know that 5 is equal to 2 plus 3. I can only substitute here because I know that 7 is equal to 2 plus 5. I can't substitute any of this stuff down here. If there was a 9 up here somewhere, I could maybe. But I can't substitute this into any of this because none of this is equal to 9. So you have to substitute only things that are equal. So let's look at an example of this. And I've given us kind of some space to try to work to maybe make this a little bit easier to deal with and to organize ourselves. So we've got this equation here that says y is equal to x minus 20. And x plus y is equal to 84. The first thing you want to do is look at your equation and see which one is already solved for a variable. And I have this equation that is y equals x minus 20. So this is the thing that will be the substitute. Because I know what y equals, I know what I can substitute for y. So in the second equation where there's a y, I know I can replace it with the thing that y is equal to. So if y is equal to this, I can put this in its spot. So I'm going to solve for my first variable by making a new equation using that second equation. So I have x plus, now where y is, I'm putting x minus 20. And I do substitution in parentheses because that helps me to make sure if I've got to multiply anything that I have that correct. You won't always need parentheses, but it's a good idea to just use them. 84, sorry. And then I'm going to solve this equation. So I have this real basic, simple equation. Now, where I have these parentheses here, I would normally do distributive property, but all that's out here is a positive 1, which pretty much means the parentheses just go away, right? So I'm going to just go ahead and combine terms. So I have x plus x will give me 2x minus 20. And then to continue solving that, I'll add 20. And this is just basic equation like what we did in the first unit. 104. And I'm going to divide by 2. So x is 52. So in my solution, the x part of my ordered pair is going to be 52. But I'm not done because I have to have the y. So to get y, and this is actually easier, you go back to your original equation that was y equals. And you're going to put your 52 in place of x. Because that's what x equals. And then you're going to solve that. So y is going to equal 32. And that's the basic idea behind substitution. Let's do some more. So this one, they're both actually in y equals, which means we can choose which one we use as the substitute. It does not matter which one you decide to use. So I'm just going to let the top one be the substitute. And it's going to substitute, remember, for y in the bottom. I can only substitute something that is exactly the same. So if y equals 6x, I can replace y with 6x. So my new equation is going to be 6x equals 5x plus 7. So I've done a replacement there, a substitution. I put what y is equal to in place of y. And then I'm going to solve that little equation. So now I've got x's on both sides. So remember, when you have x's on both sides, you've got to swap sides. So I'm going to... I always think I can pan, and then I realize I can't, and then I get grumpy. So I'm going to move the 5 by subtracting it. Why did I write a 4? Subtracting 5. Just kidding. So 5x minus 5x will cancel. I'm going to subtract it over here. What I do to one side, I do to the other. The 7 can just come down. 6 minus 5 is 1x. And then you can divide by 1 or not. It's the same thing. So x is 7. Oops. Boop. All right. Oh my gosh, y'all, I keep doing that. Goodness. So 7. Now to go back and get y, I'm going to substitute back into the original y equals equation. And you really could sub into either one and get the same thing. But if y equals 6x, then I can find y by doing 6 times what I just got for x. And so y is going to equal 42. All right. Let's do another one. We'll do a couple more together, I think, and then we'll let you guys try one. So here I have 2x minus 3y equals -1, and I have y equals x minus 1. So when you look at that, the first thing you've got to ask yourself is, what can I use for the substitute? And you can recognize what you're able to substitute by which equation is solved for your variable. So when I look at these, I have this bottom equation that is in y equals form. It has been solved for y, which means I have a substitute for y. So if y equals x minus 1, I can go to the top equation and I can replace the y with x minus 1. Now the difference for this one is that I've got a number attached to my y, but I can't replace the entire 3y term because I don't know what 3y equals. I only know what y equals. So when I do this substitution here, I've got to make sure that I'm considering that this is just y. The 3 is still going to have to stay in my new equation. So when I go to create this new equation, my equation's got to read 2x minus 3. I'm just going to take that y out and put in x minus 1. So notice in this, everything else is still exactly the same as it was in the original. 2x minus 3 equals -1. All that part is still here. I just took the y and did the substitution with that one piece. And so I'm going to solve that equation to find the value of x. So this is a little more complicated equation. Still not something that is hard for you to do. You all know how to do solving equations left, right, backwards, forwards, in your sleep maybe. So I'm going to start by distributing that negative 3. So my 2x comes down. Negative 3 times x is negative 3x. Negative 3 times negative 1 is positive 3. Bring down my negative 1. Combine like terms, so 2x and negative 3x together become negative 1x. Bring down my negative 1. Now I'm going to subtract 3 to cancel the 3 off of the left. Gives me negative 4. Bring down my negative 1x. And then my last step here is to divide by negative 1. So that means x will equal 4. So I know 4. Now to get the value of y, again, I'm going back to the substitute equation. And y will equal 4 minus 1. So y has to equal 3. And again, I know you can get the answers to these in Desmos. I 100% get that. And if it was me and I was asked to solve this, there's no way in the world I would make a choice to do all of this stuff instead of just throwing this equation in Desmos and getting my solution. But when you take your state test on this, it is very, very likely that they will ask you a question specifically about the method of substitution or the method of elimination. And the kinds of things that they will ask you, especially for substitution, is going to be something like, little Johnny wanted to use substitution to solve the system of equations. Here's his work. And they're going to show you all this stuff, and they're going to ask you to tell where he messed up. So if you don't know how this process works, you'll never be able to identify the place where he makes that mistake. So that's why it's important that you can learn this method so that you're able to find that spot for this year's test. And then for when you take Algebra 2 or when you take your ACT, this is how you're going to have to be able to do it because you don't have Desmos to just throw your equation in and graph. So you need to understand this well enough that you can do it no matter when it's presented to you, because you're going to see that later on your state test. You're going to see it on your ACT. You're going to see it in Algebra 2. So don't just check out because you know that you can do this in Desmos. I get that, and I think that is wonderful. And when you take your state test, that's 100% what I want you to do because I want you to for sure get those questions right. But I also need you to learn these other methods too. So just keep that in mind as we're working through these. I know it's a lot of work, and it takes a while to do each one, but it's important. Okay, soapbox over. Let's do one more together and then let y'all pause the video and try a couple on your own. So this one gives us y equals negative 2, and then 4x plus or minus 3y equals 18. So to identify the substitute, I have a y equals equation, which means negative 2 is my substitute. That means in my second equation, I'm going to replace the y with negative 2. Sorry, y'all, I got caught up with talking to somebody, so I don't know where I was actually at with talking about this. So if we know that the y is equal to negative 2, that's going to be my substitute in place of the y in this second equation. So I'm going to move that y out and put negative 2 in its spot. So my equation is going to be 4x minus 3 negative 2 equals 18. And so I'm going to multiply that. So 4x, negative 3 times negative 2 is going to be positive 6. And then I'll subtract 6. Bring down my 4x. Divide by 4. And so x is going to be 3. Now to solve for y, you could put 3 in place of the x in that second equation, but you really don't need to do that because we solve for y using the substitute equation. And the substitute equation actually tells me exactly what y is. Y is equal to negative 2. So 3 negative 2 has to be my solution there. We don't have to solve it because it gave it to us this time. I'd like you to take a minute, and there are 2 of these for you to try. Might be 3 of them. Do all the ones that say you try it, however many that is, and see what you get for those, and then come back and see if you were correct. Make sure you pause the video and actually work all 3 of those out, or however many of them there are out, and then check and see if you were correct. Okay, take a look at this one. If you solved it, you should have set it up where you replaced the y in the top equation with 4 minus 5x. And so you had 5x plus 4 minus 5x equaled 3. When you solve that, your x's become 0x. And so remember, when you get 0 for your x, you either have no solution or an infinite number of solutions, depending on whether you have a true statement or a false statement. 0 does not equal -1. So that means this is a false statement. There is no solution. So you don't solve for y if there's no solution. It's just no solution. And then on the second one, you would have substituted 4x minus 2 in place of the y from the top one. Again, because that's what y equals. So I had 4x minus 2 minus 3 equals 2x. And I solved that. So I ended up putting a plus 0 over here, so I would have x's and numbers on both sides, and I could do the swap. Forgot to cross this out. And so when you finish that, you get the x is 2.5 or 5 over 2 if you put that. And then you solve and you get y ends up being 8. All right, if you missed either of those, pause the video and see if you can get, or correct it, find your mistake and see what you did wrong there. I'm going to go ahead and stop this video right here, and then I'll upload a part 2 of this doing just elimination in a few minutes. So this video is going to end in just a second.